Hello again. Happy Wednesday, I guess. If you're watching this on Wednesday, granted, you could be doing it all in one day too. That works too. Okay, so we're still in section 1.1 of the textbook, where we just learned about individuals and variables and whether those variables were categorical or quantitative. Okay, so continuing on here, another example. This example is about what teens post. Okay, and it tells you here that the percentages of 12 to 17-year-olds who post various types of personal information on their social media profiles, according to this survey done in 2012. So clearly it's outdated, but it's all good. All right, so type of personal information, photo of themselves, school name, city or town, email, and cell phone number. And then this is a percentage, right? So you definitely want to pay attention to that percentage who post, right? So 91% of these 12 to 17-year-olds post photos of themselves on their social media profiles. Okay, and then they just ask us some questions about it. In this case, they want you to make a well-labeled bar graph to display the data. So if this was an AP class, which it's not, but I'll say that a lot, you guys, because that's kind of the world I've lived in. The AP exam for statistics does not have bar graphs on it. Okay, so this chapter is just kind of introducing you to graphs that you know. You should hopefully feel pretty comfortable with creating a bar graph. And if I was going to be teaching this course at a college, again, we would not do bar graphs either. Okay, so this is just kind of a review. So what do they want in statistics, regardless of the graph? Well, what you have to do is you have to figure out what you're graphing. So obviously you need to draw just a simple bar graph like you normally would. And then in statistics, it's important that you guys are labeling axes, right? So if you're going to take a quiz with me or a test with me, having the axes labeled would count. And so if you're going to do this, you're going to do this label would be, let's do type of, zoom out here a little bit, type of information. Okay, so type of information. And then what types are they? Well, let's just kind of abbreviate here. We've got a photo. You've got a school name. You've got a city or town. You've got email. And you've got a cell number. Okay, and if you have a ruler, that'd be awesome. I'm sitting at home at my desk because it's Monday, and I don't have a ruler, so it's not perfect. Okay, and then what are we going to do here? Well, we're gonna do bars, right, that represent the percentage who post pictures of themselves. So clearly over here, right, on this side, you're going to have a percentage. Percentage of teens who post. Okay, and obviously we're going to go up to 100%. So let's just kind of do some labels here. We'll do 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. 10, 20, 30, 40, 50. Okay, and we'll just do a couple numbers so we can kind of see where we're at. Okay, so pretty straightforward, right? Hopefully we've all done a bar graph and we're not stressed out at this point. We got to get up to 91%, which is going to be right about there. I'll just do a top bar and then we'll draw it in. School name, 71%. So there's 50, 71, somewhere right around there. And then 71 again for city or town. And then 53, so obviously down lower. That was for email, and then cell numbers down even lower at 20, because who wants to post their cell phone number? Okay, so you just draw in your bars. No tricks here, you guys. There's nothing really complicated at this part. And that would be your bar graph. And where this class is going, again, this is chapter 1. Really, the money that you make as a statistician is being able to graphically display data, but then more importantly, say something smart about it. And we haven't learned anything, right? That isn't common knowledge, right? We all know how to do a bar graph. You can make some basic statements here, right? The highest percentage of things that are posted are photos, with the smallest being their cell phone number, right? School name, city, and town seem to fall right around the same. With email being a little bit less than those two. So just saying basic things, right? Your job as a statistician is to provide data and graphical displays to people who make decisions, right? And then with that display, say something intelligent, and that's where we're headed. Okay, so would it be appropriate to make a pie chart? So this is just a weird question. What's up with the pie chart? So if you think about this, right, if you did a pie chart, it's basically just a fancy name for a circle graph. It wouldn't make sense because look, you have 91% post pictures of themselves, right? So these don't add up to 100, right? Not adding to 100. So it would not make sense to try to put that in a pie because this pie graph is supposed to represent 100%. And so no, it would not make sense to use a pie graph right? Because each percent in the table refers to a different type of information. Refers to different types of information. Right? Not to parts of a whole. And I'll reread that for you guys. Okay, so no, it would not make sense to make a pie graph because each percent in the table refers to different types of information, okay, not to parts of a whole. So when would it make sense to do a pie graph, right? Well, if you were talking about one thing and then breaking that one thing up into percentages. For instance, if you did, if this was just, right, if this was just a photo of themselves, if you were just focused on that and you had different age groups like 10 to 12, 13 to 15, etc., right, then you could break this thing up into different percentages that all add up to 100. Okay, but in this case the answer is definitely no. Okay, all right, so the next part here on the second page, this is just good old advertising, right? I mean, look, the one thing you guys are going to learn from statistics is that everybody is lying to you, right? The media, everybody can take data and spin it, right? It's called marketing to try to convince you guys to do something, right? Buy something, believe something. And so you just want to, the older you get, obviously, think about what it is that they're trying to portray. For instance, right, in this game, you've got in 2008, 2009, basketball player Dwayne Wade averaged 7.5 assists per game and 2.2 steals per game, right? So these numbers are not confusing to us, right? We all know 7.5 and 2.2. And what do we know about them? Well, I mean, double 2.2, right? And you get 4.4, right? So if you double it, you get 4.4. If you triple it, right, what do you get? You get 2.2 times 3, you get 6.6, right? And if you multiply by 4, right, you would get 2.2. Oh my gosh, keep saying that, right? 2.2 times 4, we're at 8.8. Okay, and so we're somewhere in between, right? 7.5 is somewhere in between 3 to 4 times as big, right? Well, look at this picture, okay? And this is, a graph. Explain what's wrong with the following graph and how to make it better. Well, does that legitimately kind of explain through a picture how much more assists Dwayne averaged versus the steals, right? This ball, right? How many of these little guys could you draw in there, right? Just start thinking about that. 1, 2, 3, 4, 5, 6, 7, 8, right? It's at least 8 times as big, if not more. Okay, so just looking at this graph, if you didn't have the numbers, you would say, man, Dwayne Wade is way better at assists than he is at steals, when that's not really the case, right? He's only about 3 to 4 times as much as far as assists go in comparison to steals. Okay, so a lot of times graphical displays, even though you find them in the newspaper, you find them on TV, it's not real, right? It's definitely marketing. Okay, so what's wrong with this one? DirecTV stomps the competition. Yeah, this is classic. DirecTV is not doing well because nobody wants to pay $130 when they can just buy a Netflix account or Hulu or something like that. So their business plan's not going great for them. But again, right, this says 95, right, of your favorite HD channels. Dish Network has 81 and 56. Okay, so I mean, just looking at this one, 56 if you're talking about cable. This rectangle is clearly way bigger than twice the size of that. And this is, I mean, if you double 56, you're over 95. Okay, so this is to catch your eye and make you believe that DirecTV is much better than Dish Network or cable. And everybody else thinks so too, right? So it's just a marketing ploy. Okay, so again, short days this week. Short lessons, just getting you guys used to Edpuzzle. I know from my AP Calc kids that it's frustrating in Edpuzzle because it's a little bit small, and I write small and all that stuff. But we'll figure it out, you guys. There's bigger problems. We just got to hang tight. I told my Calc kids too, you guys. If you just get sick of how small it is, feel free to go watch it on YouTube. But if you don't hit play on the Edpuzzle, you're not going to get credit. So if you want to watch it on YouTube and then hit the play button and walk away, that's totally up to you, right? You're going to get credit for Edpuzzle playing through and completing it in entirety. Okay, all right. See you guys in the next lesson.